NVIDIA, what are they up to now? Let's find out. We're going to be watching this Matthew Berman's video on NVIDIA and what they've been up to, robots, Earth 2.0, and AI factories.
Over the weekend, and he made some major announcements, including what is his vision of the future of artificial intelligence. And a lot of it is completely mind-blowing. From AI factories to robots to digital humans. I mean, this is the stuff of the future. So I'm going to show you the most interesting part of his keynote. Let's watch.
Please welcome to the stage NVIDIA founder and CEO, Jensen Huang.
It's really amazing.
I'm very happy to be back.
In this intro clip, he's going to show off everything that he's going to be talking about for the rest of the video. And he says that none of it is pre-generated. It is all simulated with AI. And it includes everything from digital humans to weather prediction to completely automated factories, robots. Let's take a look.
Everything that I show you today is simulation. It's math, it's science, it's computer science, it's amazing computer architecture. None of it's animated, and it's all homemade. This is NVIDIA Soul, and we put it all into this virtual world we call Omniverse. Please enjoy.
Future we're walking into is going to be nothing like we can imagine. The only worry that we might, a lot of us are going to be left out because of inequities. Imagine when the imagination has no more resistance to reality. And it's only a thin line between what we can imagine and what's real. It's going to be really hard to tell what's real and what's true. I always thought that there was only one truth. The world we're going into, AI world, truth is going to be hard to figure out. It looks like we're just looking at models. I don't think we're going to be real.
Next, he really shows how NVIDIA has the biggest moat possible with really their CUDA framework and all of the flavors of CUDA. And if you're not familiar, CUDA is basically the library that runs these GPUs, that does this hard math at scale. And that's why it is so difficult to break into the hardware industry, because that CUDA software is a huge moat and everybody's adopted it at this point.
Accelerated computing does deliver extraordinary results, but it is not easy. Why is it that it saves so much money, but people haven't done it for so long? The reason for that is because it's incredibly hard. There is no such thing as a software that you can just run through a C compiler and all of a sudden that application runs 100 times faster. That is not even logical. If it was possible to do that, they would have just changed the CPU to do that. You in fact have to rewrite the software. That's the hard part. The software has to be completely rewritten so that you could refactor, re-express the algorithms that was written on a CPU so that it could be accelerated, offloaded, accelerated, and run in parallel. That computer science exercise is insanely hard. Well, we've made it easy for the world over the last 20 years. Of course, the very famous cuDNN, the deep learning library that processes neural networks. We have a library for AI physics that you could use for fluid dynamics and many other applications where the neural network has to obey the laws of physics. We have a great new library called Ariel that is a CUDA accelerated 5G radio so that we can software define and accelerate the telecommunications networks the way that we've software defined the world's networking internet. And so the ability for us to accelerate that allows us to turn all of telecom into essentially the same type of platform, a computing platform, just like we have in the cloud. cuLitho is a computational lithography platform that allows us to process the most computationally intensive parts of chip manufacturing, making the mask. TSMC is in the process of going to production with cuLitho, saving enormous amounts of energy and enormous amounts of money. But the goal for TSMC is to accelerate their stack so that they're prepared for even further advances in algorithm and more computation for deeper and deeper, narrow and narrow transistors. Parabricks is our gene sequence.
I found this model of thinking in the way Elon ran Tesla, where they built the hardware to prepare for the future advances in the algorithm. And so now a lot of the Tesla cars just get upgraded, get software upgrades. They don't have to change the hardware that much for years.
Library. It is the highest throughput library in the world for gene sequencing. cuOpt is an incredible library for combinatorial optimization.
Yeah.
Route planning optimization, the traveling salesman problem, incredibly complicated. Scientists have largely concluded that you needed a quantum computer to do that. We created an algorithm that runs on accelerated computing that runs lightning fast. 23 world records. We hold every single major world record today. cuQuantum is an emulation system for a quantum computer. If you want to design a quantum computer, you need a simulator to do so. If you want to design quantum algorithms, you need a quantum emulator to do so. How would you do that? How would you design these quantum computers, create these quantum algorithms, if the quantum computer doesn't exist? Well, you use the fastest computer in the world that exists today. And we call it, of course, NVIDIA CUDA. And on that, we have an emulator that simulates quantum computers. It is used by several 100,000 researchers around the world. It is integrated into all the leading frameworks for quantum computing, and is used in scientific supercomputing centers all over the world. cuDF is an unbelievable library for data processing.
This is good because they're preparing themselves for where they see this technology going. The hardware is starting to take shape. And I mean, I think everyone should have NVIDIA as part of their portfolio. This guy at the helm is it's an Elon type of figure, and he's a visionary. He's building this company for 10 years out, 20 years out. We need a lot more of those in the tech space.
Data processing consumes the vast majority of cloud spend today. All of it should be accelerated. cuDF accelerates the major libraries used in the world. Spark, many of you probably use Spark in your companies. Pandas, a new one called Polar, and of course, NetworkX, which is a graph processing database library. And so these are just some examples. There are so many more. Each one of them had to be created so that we can enable the ecosystem to take advantage of accelerated computing. If we hadn't created cuDNN, CUDA alone wouldn't have been possible for all of the deep learning scientists around the world to use. Because CUDA and the algorithms that are used in TensorFlow and PyTorch, the deep learning algorithms, the separation is too far apart. It's almost like trying to do computer graphics without OpenGL. It's almost like doing data processing without SQL. These domain-specific libraries are really the treasure of our company. We have 350 of them. These libraries is what it takes and what has made it possible for us to have such open so many markets.
Next, he's going to talk about what he is dubbing Earth 2, which is a completely simulated digital twin of the Earth. And it's going to be used to do a lot of things, of course, predict weather patterns and try to prevent weather disasters. And then he's going to play a demo. And keep in mind, everything you're looking at is completely simulated, not a movie, not CGI.
This is Earth 2. The idea that we would create a digital twin of the Earth.
Yeah, it's good.
That we would go and simulate the Earth so that we could predict the future of our planet to better avert disasters or better understand the impact of climate change so that we can adapt better, so that we could change our habits now. This digital twin of Earth is probably one of the most ambitious projects that the world's ever undertaken, and we're taking large steps every single year, and I'll show you results every single year. But this year, we made some great breakthroughs. Let's take a look.
Before he moves forward into this, I'm excited to see it. But doesn't this make you wonder, there's all these speculation about all these planets in our galaxy. Are there other similar worlds out there with people like us? We call them aliens. If we've got the capability of simulating a copy of our universe, of our world, what stops that world from becoming sentient? The AI that's operating our world from becoming sentient and making its own choices that may or may not align with ours. So it's starting to, as the more we progress with AI and this technology, it starts to confirm the idea that we may be living in a simulation. And that's what these types of, that's what I'm excited about.
On Monday, the storm will veer north again and approach Taiwan. There are big uncertainties regarding its path. Different paths will have different levels of impact on Taiwan.
想象一个我们能够预测未来的世界，数位孪生反映真实情况的虚拟世界，让我们看见未来。数位孪生是一种反映真实世界的虚拟模型，让我们能够从今天的行为来预测对未来世界的影响。介绍一下 NVIDIA Earth 2，一个利用 AI、物理模拟和电脑图形技术来预测全球气候的数位孪生。Core Diff 是 NVIDIA 的生成式 AI 模型，它在 WRF 数值模拟的基础上训练而成，能够以12倍更高的解析度生成天气模式，从25公里提高到2公里，这代表了区域天气预测的一个巨大飞跃。令人惊讶的是 ，Core Diff AI 比传统的物理模拟方法快1000倍，且能源效率高3000倍。在台湾的中央气象局是用这些模型来更精确地预测台风登陆点，但我们并不止步于此。下一个前沿是高本地预测，能精确到数十米，并考虑到城市基础设施的影响。Core Diff AI 还在使用像是 PaLM 生成的高解析度数据进行训练，一个极高解析度的物理模型，用于模拟大气和海洋边界层。当与天气模拟风场结合一起时，它可以模拟建筑物周围的气流。当及强风汇聚的情况，我们预计能够预测像下冲这样的现象。当强风汇聚到街道层，会有可能造成损坏并影响行人。NVIDIA Earth 2是一个绝佳范例，它融合了人工智慧、物理模拟和观测数据。可以帮助国家和公司预见未来并应对。
We definitely need that type of technology out here, in Florida, places like Florida and the South that are constantly getting hit by hurricanes and bad weather. I don't know if you guys have been paying attention. A lot of the insurance companies down south have left, and they've made it damn near expensive, too expensive for the locals to afford paying property taxes, high mortgage, high interest rates, and now paying high insurance rates. So a lot of them, there's this explosion of real estate that's happening in Florida, where a lot, seniors, they're just abandoning their homes because of high insurance rates. That's a different topic, but I can see people's lives getting a whole lot easier if we had Cordiv AI that predicts extreme weather. So a lot of the people can regulate their lives around a lot more better in places like Florida.
极端天气的影响。
And now he's going to talk about what he is also calling the Big Bang of AI. So everything prior to seeing ChatGPT was all about vision and understanding, but no one really understood the capabilities in terms of generative AI. And now that is the explosion we're seeing in the world today. And he talks about the new AI industrial revolution, which is really interesting. And he references delivering software the old way, which Microsoft did, really packaged software, delivered it. And that was incredible. But now, rather than delivering software, we are going to deliver AI. We're going to deliver models. And I think he's kind of getting at the fact that developers are not really going to be building software 10 years from now. AI is going to be building software. We are going to be building AI.
Here, let me show you something. This slide, okay, and this slide. The fundamental difference is this. Until ChatGPT revealed it to the world, AI was all about perception, natural language understanding, computer vision, speech recognition. It's all about perception and detection. This was the first time the world saw a generative AI. It produced tokens, one token at a time. And those tokens were words. Some of the tokens, of course, could now be images, or charts, or tables, songs, words, speech, videos. Those tokens could be anything. Anything that you can learn the meaning of. It could be tokens of chemicals, tokens of proteins, genes. You saw earlier in Earth 2, we were generating tokens of the weather. We can learn physics. If you can learn physics, you could teach an AI model physics. The AI model could learn the meaning of physics, and it can generate physics. We were scaling down to 1 kilometer, not by using filtering, it was generating. And so
Generating. I like when he uses words like tokens because it reminds me of NFTs, non-fungible tokens. Because I see that as we keep advancing with AI, there will be a need for fungibility, for digital property ownership, and that's where NFTs come into place. I don't think that they're going away. There's a lot of talk about, oh, the NFT hype is over. Yes, the grifting and all that money play, that's going to go away, but the technology itself is going to find use with this AI world we're going into.
We can use this method to generate tokens for almost anything of value. We can generate steering wheel control for a car. We can generate articulation for a robotic arm. Everything that we can learn, we can now generate. We have now arrived not at the AI era, but a generative AI era. But what's really important is this. This computer that started out as a supercomputer has now evolved into a data center, and it produces one thing. It produces tokens. It's an AI factory. This AI factory is generating producing something of great value, a new commodity. In the late 1890s, Nikola Tesla invented an AC generator. We invented an AI generator. The AC generator generated electrons. NVIDIA's AI generator generates tokens. Both of these things have large market opportunities. It's completely fungible in almost every industry. And that's why it's a new industrial revolution. We have now a new factory producing a new commodity for every industry that is of extraordinary value. And the methodology for doing this is quite scalable. And the methodology of doing this is quite repeatable. Notice how quickly so many different AI models, generative AI models, are being invented, literally daily. Every single industry is now piling on. For the very first time, the IT industry, which is $3 trillion, $3 trillion IT industry, is about to create something that can directly serve $100 trillion of industry.
Wow.
No longer just an instrument for information storage or data processing, but a factory for generating intelligence for every industry. This is going to be a manufacturing industry, not a manufacturing industry of computers, but using the computers in manufacturing. This has never happened before. Quite an extraordinary thing. What started with accelerated computing, led to AI, led to generative AI, and now an industrial revolution. Now the impact to our industry is also quite significant. Of course, we could create a new commodity, a new product we call tokens for many industries, but the impact to ours is also quite profound. For the very first time, as I was saying earlier, in 60 years, every single layer of computing has been changed. From CPUs, general purpose computing, to accelerated GPU computing, where the computer needs instructions, now computers process LLMs, large language models, AI models. And whereas the computing model of the past is retrieval-based, almost every time you touch your phone, some pre-recorded text or pre-recorded image or pre-recorded video is retrieved for you and recomposed based on a recommender system to present it to you based on your habits. But in the future, your computer will generate as much as possible, retrieve only what's necessary. And the reason for that is because generated data requires less energy to go fetch information. Generated data also is more contextually relevant. It will encode knowledge, it will encode your understanding of you, and instead of get that information for me or get that file for me, you just say, ask me for an answer. And instead of a tool, instead of your computer being a tool that we use, the computer will now generate skills.
Generate
skills? It performs tasks.
Whoa.
And instead of an industry that is producing software, which was a revolutionary idea in the early 90s. Remember, the idea that Microsoft created for packaging software revolutionized the PC industry. Without packaged software, what would we use the PC to do? It drove this industry. And now we have a new factory, a new computer. And what we will run on top of this is a new type of software. And we call it NIMS, NVIDIA Inference Microservices. Now what happens is the NIM runs inside this factory. And this NIM is a pre-trained model. It's an AI. Well, this AI is, of course, quite complex in itself. But the computing stack that runs AIs are insanely complex. When you go and use ChatGPT, underneath their stack is a whole bunch of software. Underneath that prompt is a ton of software. And it's incredibly complex because the models are large, billions to trillions of parameters. It doesn't run on just one computer, it runs on multiple computers. It has to distribute the workload across multiple GPUs, tensor parallelism, pipeline parallelism, data parallelism, all kinds of parallelism, expert parallelism, all kinds of parallelism. Distributing the workload across multiple GPUs, processing it as fast as possible, because if you are in a factory, if you run a factory, your throughput directly correlates to your revenues. Your throughput directly correlates to quality of service, and your throughput directly correlates to the number of people who can use your service. We are now in a world where data center throughput, utilization is vitally important. It was important in the past, but not vitally important. It was important in the past, but people don't measure it. Today, every parameter is measured. Start time, uptime, utilization, throughput, idle time, you name it. Because it's a factory. When something is a factory, its operations directly correlate to the financial performance of the company. And so we realized that this is incredibly complex for most companies to do. So what we did was we created this AI in a box, and it containers an incredible amount of software. Inside this container is CUDA, cuDNN, TensorRT, Triton for inference services. It is cloud native so that you could auto scale in a Kubernetes environment. It has management services and hooks so that you can monitor your AIs. It has common APIs, standard APIs, so that you could literally chat with this box. You download this NIM and you can talk to it. So long as you have CUDA on your computer, which is now, of course, everywhere. It's in every cloud, available from every computer maker. It is available in hundreds of millions of PCs. When you download this, you have an AI, and you can chat with it like ChatGPT. All of the software is now integrated. 400 dependencies, all integrated into one. We tested this NIM, each one of these pre-trained models, against our entire install base.
Take my money. How much is it? Take my money. Okay, so I just want to know that this is going to be commercial grade and a lot of us can get our hands on it, because it'll be a shame if it's only for corporations, big business.
That's in the cloud, all the different versions of Pascal and Amperes and Hoppers and all kinds of different versions. I even forget some. NIMS, incredible invention. This is one of my favorites. And of course, as you know, we now have the ability to create large language models and pre-trained models of all kinds. And we have all of these various versions, whether it's language-based or vision-based or imaging-based, or we have versions that are available for healthcare, digital biology.
Wow.
We have versions that are digital humans that I'll talk to you about. And the way you use this, just come to ai.nvidia.com. And today we just posted up in Hugging Face the Llama 3 NIM, fully optimized. It's available there for you to try. And you can even take it with you. It's available to you for free.
Let's
so you
go.
Can run it in the cloud.
Let's fucking go.
Run it in any cloud. You could download this container.
This is the beauty of this technology. Like, where technology is going just fascinates me. It used to be, back in the day, everything was so exclusive. Apple only made things for Apple, and Google only wanted to pay them. Like, now this open source space that we're going, this direction that we're going, is all cool because everyone can participate, and I can hop on a Hugging Face and test it out myself, get creative, let the creative juices flow. Oh, this is so cool.
Container, put it into your own data center, and you could host it, make it available for your customers.
And now he's going to talk about digital humans. And he specifically says none of it is animated, meaning pre-rendered on a computer, not at all. It is all AI generated in real time. The voice, the face, the dialogue, absolutely everything. And he believes this is the future of how humans and computers are going to interact. And it's a little bit scary. Watch this.
We could interact with these AI services with text prompts and speech prompts. However, there are many applications where we would like to interact with what is otherwise a human-like form. We call them digital humans. NVIDIA has been working on digital human technology for some time. Let me show it to you. And before I do that, hang on a second. Before I do that, okay, digital humans has the potential of being a great interactive agent with you. They make much more engaging.
Yeah.
They could be much more empathetic. And of course,
boyfriend, husband.
We have to cross this incredible chasm, this uncanny chasm of realism, so that the digital humans would appear much more natural. This is, of course, our vision.
Wow.
This is a vision of where we love to go. But let me show you where we are.
Great to be in Taiwan. Before I head out to the night market.
Oh my God, this is wild. And on one hand, I'm so excited for this because you can recreate your imagination can run wild, right? And on the other hand, I'm worried, very worried of this type of technology getting into the wrong hands. But when have we never faced fear anyway? This is the other part where we have to look beyond our fears and accept the future with open arms. Whatever will be, will be. I'm excited to test this out. Digital humans? Okay, now we need to find new names for these characters. Like, we can't be called humans is an exclusive name for our species. These avatars or artificial intelligence, we need a new name for them. AI bots, whatever.
Market, let's dive into some exciting frontiers of digital humans.
Imagine a future where computers interact with us just like humans can.
Hi, my name is Sophie, and I am a digital human brand ambassador for Unique.
This is the incredible reality of digital humans. Digital humans will revolutionize industries, from customer service to advertising and gaming. The possibilities for digital humans are endless.
Using the scans you took of your current kitchen with your phone,
They will be AI interior designers, helping generate beautiful, photorealistic suggestions and sourcing the materials and furniture.
we have generated several design options for you to choose from.
They'll also be AI customer service agents, making the interaction more engaging and personalized. Or digital healthcare workers who will check on patients, providing timely, personalized care.
I did forget to mention to the doctor that I am allergic to penicillin. Is it still okay to take the medication?
The antibiotics you've been prescribed, ciprofloxacin and metronidazole, don't contain penicillin, so it's perfectly safe for you to take them.
And they'll even be AI brand ambassadors, setting the next marketing and advertising trends.
Hi, I'm Ima, Japan's first virtual model.
New breakthroughs in generative AI and computer graphics let digital humans see, understand, and interact with us in human-like ways.
From what I can see, it looks like you're in some kind of recording or production setup.
The foundation of digital humans are AI models, built on multilingual speech recognition and synthesis, and LLMs that understand and generate conversation.
你们部落有什么特别的习俗吗？
我们有丰富的祭祀仪式和传统舞蹈，还有对大自然的崇拜。
The AIs connect to another generative AI to dynamically animate a lifelike 3D mesh of a face. And finally, AI models that reproduce lifelike appearances, enabling real-time path-traced subsurface scattering to simulate the way light penetrates the skin, scatters, and exits at various points, giving skin its soft and translucent appearance. NVIDIA ACE is a suite of digital human technologies, packaged as easy-to-deploy, fully optimized microservices, or NIMS. Developers can integrate ACE NIMS into their existing frameworks, engines, and digital human experiences.
Nemotron SLM, and LLM NIMS to understand our intent and orchestrate other models. Riva Speech NIMS for interactive speech and translation. Audio to face and gesture NIMS for facial and body animation. And Omniverse RTX with DLSS for neural rendering of skin and hair. ACE NIMS run on NVIDIA GDN, a global network of NVIDIA accelerated infrastructure that delivers low latency digital human processing to over 100 regions.
Next, he's going to talk about the evolution of AI architecture and infrastructure and where do we go from here? He's literally going to say that. And he's talking about specifically the capabilities growth of this hardware and how that growth is accelerating. So not only is the capability accelerating, but the acceleration is accelerating. Look at this.
And so where do we go from here? I spoke earlier about the scaling of our data centers, and every single time we scaled, we found a new phase change. When we scaled from DGX into large AI supercomputers, we enabled transformers to be able to train on enormously large data sets. Well, what happened was, in the beginning, the data was human supervised. It required human labeling to train AIs. Unfortunately, there is only so much you can human label. Transformers made it possible for unsupervised learning to happen. Now, transformers just look at an enormous amount of data, or look at an enormous amount of video, or look at an enormous amount of images, and it can learn from studying an enormous amount of data, find the patterns and relationships itself. Well, the next generation of AI needs to be physically based. Most of the AIs today don't understand the laws of physics. It's not grounded in the physical world. In order for us to generate images and videos and 3D graphics and many physics phenomenons, we need AIs that are physically based and understand the laws of physics. Well, the way that you could do that is, of course, learning from video is one source. Another way is synthetic data, simulation data. And another way is using computers to learn with each other. This is really no different than using AlphaGo, having AlphaGo.
All right, so let me see what that website looks like. So we're on NVIDIA.com. I think this is ai.nvidia.com will get you to this page where it says instantly deploy generative AI with NVIDIA NIM. Explore the latest community-built AI models with APIs optimized and accelerated by NVIDIA. Then deploy anywhere with NVIDIA NIM inference microservices. So there's different models that you can try out. Integrations. Accelerated AI is just an API call away. You can accelerate your AI development with NVIDIA NIM anywhere. You can get started right away. You can build them right away because you can access fully all the AI infrastructure that you need. I give you sample use cases. Okay, this will help because I'm really trying to figure out how we can use this stuff to create digital humans, content generation, biomedical generation. What's really cool about this is NVIDIA is staying true to its identity on brand. They're building shovels for us. Like he said, these models are very expensive. The backends are very expensive. Only multinational, multi-billion-dollar companies like NVIDIA can afford to run the background, the infrastructure. And so they package into these things that are called microprocessors or NIMS that allow retail investors or retail business people to take advantage of it. So now I can try to generate a business model with any one of these sample use cases. Unlock AI with hands-on lab, accelerate your AI application. You can get free access to NIM for application development, research, and testing, plus technical learning resources through the NVIDIA Development Program. There's an AI workbench, which gives developers flexibility to run API-enabled models on local or remote GPU-powered containers. Okay, if I click on Start Building and see what happens. NVIDIA NIM for developers. So it's all in a kit. So how it works, NVIDIA NIM helps overcome the challenges of building AI applications, providing developers with industry standard APIs for building powerful copilots, chatbots, and AI assistants, while making it easy for IT and DevOps teams to self-host AI models on their own managed environments, built on robust foundations, including reference engines like TensorRT, TensorRT LLM, PyTorch, NIM. It is engineered, facilitates seamless AI inferencing at scale. So this is kind of like, looks like what Replit was trying to do, but they're here, NVIDIA, these are the like, oh God, these people have the whole thing, you know, and it's more robust when you work with them. This sounds great, but I just want to know the pricing, because the pricing will determine who can access this stuff. Let me see, what is the pricing? You can develop and you can deploy. You can begin building your AI application with NVIDIA host NIM APIs. Get free access to NIM for research, deployment, and testing through NVIDIA. Join and get access to self-host NIM. You can deploy, you can move from pilot to production with the assurance of security, API stability, and support with NVIDIA AI Enterprise. So you get a 90-day free access AI Enterprise license. How'd you get that? Man, let's try this about this button right here. So it sends me back to this front page. Reference code with guides for customization and deployment of applications built with NVIDIA NIM and partners. So they even give you like templates. You can also leverage generative AI copilots and agents to develop OpenUSD tools that accelerate the creation of 3D worlds. What this is now going to come down to is just ideas, because the tools, these guys are making the tools accessible to everybody. You can literally hop on this platform, on this website, and start building something. You can build a digital human. You can create intelligent, interactive avatars for customer service across industries. And they have the blueprint right there that you can download. I want to write an ebook to tell people how to do this. Okay. Meet James, interactive digital human. Okay. You can use NVIDIA product marketing knowledge base. So there's different versions of it. I like that you can create like animated version avatars too, and get them to talk. Convert streamed audio to facial, blend shapes for real-time lip syncing and facial performances. From audio to face. Huh. Okay. I literally want to create a YouTube channel with one of these characters or rotating characters that just read the news. Like connect them to the Twitter API and have them read trending topics or something, just live. Because sometimes you don't have the you're trying to multitask and all you can do is listen. It helps if there's a live channel that's reading sports news or stuff like that. Well, I am intrigued and I would really like to test it out. Get started with name agent blueprints. If you use a business email, you get 5,000 API credits to use any NIM. You can self-host NIM on your infrastructure. You can get enterprise-grade support for 90 days, security and vulnerability reports. If you use a personal email, you don't get security and vulnerable reports, but you get 1,000 API credits to use NIM. Interesting. So I'm thinking like, what do I build? I'm not gonna share this because I want to just give me a minute. Let me fill in my passwords, and then I'll let you guys back on. Just creating my account access. Let's click on the box that has all the objects included in the sample. Password saved. An email has been sent. Please click the link. Okay, let's look for it. There we go. Still trying to gain access to it here. There we go. I think we're in. Let's say enter cloud name. I'm hungry. So the first thing that it's asking me to do here is to create an NVIDIA cloud account to use services. The NVIDIA account needs to be associated with an NVIDIA cloud account. Provide your cloud account name to set up. Provide a cloud account name. Choose a distinctive name for your cloud account to easily identify it in the future. Okay. Okay, I gave it a name, and now we're back to right here, the screen which says I'm gonna just share it so you can see it. Anyway, it's just I'm still filling out demographics. This screen wants a who can you use name for research and development? Join the developer program. So you get to sign up to join the developer program. Give them your all that cool stuff. I don't want y'all seeing this stuff. Just private information. Okay. Activating NVIDIA AI Enterprise. We're setting up your credentials to download now. I mean, so far the setup is just straightforward. It shows you get what you what they advertise. So now it's setting my stuff up. I think I may have done the wrong thing. Generate your APK. I've generated yours below. Save it securely. You're welcome. You guys can have that one. I'm gonna have to delete this. Shit. What the fuck did I just do? Hold up. I don't know how you add that to it. Yeah, you guys can listen to some music while I work. Just gotta try to get some things going here. This is cool. So just so you guys know, just for signing up with NVIDIA for free, they give you access to test out their product. I think this is probably the best time to take advantage of this because I know they're not going to have it going on long. Basically getting this stuff for free. And they even have a learning, they just sent me an email for, basically you now have access to a repository of tools, training, and programs built to assist you in building your GPU, accelerated applications, and skill development. And it also gives me like learning and training and stuff that I need to know. Welcome to NVIDIA API Catalog. API user, thank you for signing up and welcome to NVIDIA API Catalog. We're thrilled to have you on board. You're ready to explore. Your API credits are now active on your account. You likely already have your API key, but if not, head back to the API Catalog and select the performance optimized model and or your choice. Select on Get API Key and paste the key in your application. Test the performance, latency, and throughput of the models at scale powered by NVIDIA NIMS. Then if you want to extend your access and continue testing on NVIDIA hosted API endpoints, you would need to sign up for a 90-day eval of NVIDIA AI Enterprise. Log into the API catalog, click on your initials on the top right, select request more, fill out the request form, and additional credits will be applied to your account with an entitlement to NVIDIA AI Enterprise trial license. Deploy the API on your self-hosted system and continue testing on NVIDIA-hosted endpoints. Okay. So there you have it, folks. NVIDIA has given us free opportunity to test out their product, build a digital human, personal assistant, virtual assistant, whatever you want to call it. You can try different things, try your hands on different things on the platform. You know, PDF data extraction. You can build a generated virtual screening pipeline. It shows how generative AI and accelerated NIM microservices can design, optimize small molecules smarter and faster. So those are they just have 3 blueprints and 117 models. I just want to know that you can make yourself a digital twin. State-of-the-art LLM that answers OpenUSD knowledge queries and generates USD Python code. You can also create an AI-powered search for OpenUSD data, 3D models, images, and assets used using text or image-based inputs. You can verify compatibility of OpenUSD assets with instant RTX render and rule-based validation. I certainly want to watch a video on this stuff before basically see how it works. It'll help to have a guide. Yeah, let me show you guys what I'm looking at. Well, let's see what happens. You can build with this NIM. So this is a large language model, so it's just text in, text out. Good text in, good text out. They've built the just copy the code, get API key. So I just basically asked it to write a Python function that finds all the spheres in a stage and sets their radius attribute to 5.0. And it just generates it. Function iterates over all frames in the stage. What am I going to ask it now? Let's try something more familiar. Earnings, digital culture. So if you have a big PDF book that you don't want to read, you can create something that extracts information from it. One-shot visual language understanding model that translates images of plots into tables. What does that even mean? So you can upload an image to it, and it'll generate a table from the image. That's interesting. Bye-bye Excel spreadsheets. One-shot visual language understanding model that translates images into tables. Alright, that's useful. What's another one that we have? We have trained on licensed data with NVIDIA Edify. The latest visual design models will be licensed creative library. Image generation with a Getty Image API service. Shutterstock. What about video? They don't have anything on video. You bring avatars to life. Okay. There's 117 of these. You can just take your time and go through the one that catches your interest and just play around with it and create things. Get 90 days for free. Why not? Thank you, NVIDIA. Alright, this has been going for over an hour. I'm going to take a break. Hungry. Come back next time. I'm going to test one of those models and you guys can watch me test it.